Okay, have a wee look at this one here. I would like to draw a wee sketch first to see what it looks like. The cost graph would be like so. Pi over 2 minus pi over 2, crossing at 1. So a 20 cross graph would be up at 20, and a 4 cost graph would go up to 4. And I want the bit in between it. So my area is going to be between minus pi over 2, and it's going to be the 20 cost graph minus the 4 cost graph. Now, to integrate that, I like to split them up. Just bring your 4 outside. Where does cos come from? Sine goes to cos, so I have no issues about balancing here. And that goes back to sine. And just putting in your wee intervals. Pi over 2 minus pi over 2. Pi over 2 minus pi over 2. So 20 sine, I'm just thinking of the sine graph here to help me get my values. 20 sine pi over 2 is 1. Take away 20 sine negative pi over 2 is negative 1. So the first bracket is 20 plus 20, which is 40. Take away the second bracket is 4 times 1. Take away 4 times negative 1. So let's take away 8, which is 32. Question 8 from the same paper. If you just scroll down to find it there. Okay, 8b. First of all, I'm going to split them up. I'm looking to see if I have the derivative of the bottom. Derivative is 3x squared. So I don't want that 2, so just put that 2 outside. So I said I wanted 3x squared. So put your 3 balance outside. Now you can log the bottom line. The next one, cosec squared. So you think of where does cosec squared comes from. Now cot goes to minus cosec squared. So I need a minus, so balance outside. I must have the derivative. The derivative of this bracket is minus 7. So I need another minus 7 here. So balance it outside by minus a 7th. Now tidying it up. 2 minuses, a 7th. This will go back to cot, and remember the derivative disappears. To integrate this one, I would split it up into x over x squared, which is 1 over x, plus, and that is 1 over x squared, which comes up as x to the minus 2. To integrate a fraction, do I have the derivative on the top? Yes. To integrate this, add 1, divide by it, and don't forget your c. And then I would just tidy that up at the end. So it's 2/3 log x cubed minus 1 plus a 7th cot 3 minus 7x plus log the modulus of x minus 1 over x plus c. So the next one we're going to look at is from the C4 paper from that year. So if we can find that, and it is question 5. So it's a straightforward wee one here. Only thing is you have to do integration by parts and product rule. And remember, u is the log and dv by dx is the other. So differentiate this derivative over the function, which gives you 1 over x. Integrate this, x cubed over 3. Now, using your right hand side of the formula, u v minus the integral of v du by dx dx. So that tidies up to give me x cubed over 3 log 3x minus x squared over 3 dx. So integrating the far one, add 1 to the power and divide by it. Now this one had limits, so your limits are 4 and 1. So subbing in your 4 cubed is 64 over 3 log 12 minus 64 over 9. take away 1 over 3 log 3 minus a ninth. And if you work that out on your calculator, you should end up with the answer 45.6. Now, one other from that paper, question 8. I've got to use substitution. So the first thing I'm going to do is do du by dx, which is cos x, derivative is just a 1. Rearrange that. So du is cos x dx. So du over cos x is dx. So I'm now going to write my integral. So I've got 3 cos x, we'll just leave that there for the time being. Sine squared is going to be u squared over 4 minus u squared. Dx is now